Today we examine Lesson 6.2, Segments in Triangles. In Lesson 6.1, we looked at angle bisectors and perpendicular bisectors that can be drawn in triangles. But there are actually many more segments that we can draw. We're going to look at 3 of those today. The first one we'll look at is an altitude. When we think of altitude, we typically think of height, like the altitude of an airplane or the altitude that you're at on a mountain. But altitude in a triangle is the perpendicular distance. It's important there that it's perpendicular from the base of the triangle to the opposite vertex. When you were back in middle school, you used this to calculate area, 1/2 base times height, and you would have called it height back then, but we know that altitude and height are really the same thing. It's the height the airplane is flying, or the height that you are up on the mountain. The tricky part about that is sometimes altitude is not actually inside of the triangle. When you have a nice triangle like this, whether it be a right triangle or an acute triangle, then the altitude is going to be nice inside from one vertex to the opposite side in a perpendicular fashion. However, when you have an obtuse triangle, the altitude can be a little tricky to find because it will not stay inside of the triangle. It will actually go to the outside of the triangle. So here we have this triangle. Maybe color it in a little bit so you can see it a little more clearly. And when I'm thinking about going from the base, which is this flat part down here, to the opposite vertex, I would want to go from this base up to this point. But if I draw anywhere inside of the triangle, the line that I would draw would not be perpendicular, wouldn't make a 90-degree angle down here anywhere. So I actually have to extend that side out and then draw a line straight down to that extended side at a 90-degree angle. But the line that I drew out here, that's our altitude, and it's outside of the triangle. It's okay for our altitude to be outside of the triangle. So here we are going to draw an altitude from side AB to vertex C. So here's side AB, and I want to draw a line that's going to be perpendicular to AB, and it needs to go through point C. So if you have something like a ruler or something at home that you can use, or you can simply use the corner of something that you have, but you're going to want to be able to line up C with AB and make sure that you're making a 90-degree angle there. So it's going to come straight down and make sure that you have a 90-degree angle happening. Now I'm going to eyeball mine, so to speak, but you may want to use a straight edge or something for yours. That's up to you. Alright, here we have an obtuse triangle. This angle is bigger than 90 degrees. Here's side AB. If I draw from C to AB, let me just sketch a few of those in. If I were to draw it inside of the triangle like this, you'll see none of the angles I am making down here are 90-degree angles. That doesn't work. So we are going to need to take our straight edge and extend side AB out a little farther. Then we can draw from point C up here down to the extension of AB at a 90-degree angle. So this line right here would be our altitude. Now in this one I wanted to just show you that the triangle doesn't have to have a nice flat side along the horizontal here at the bottom. We're supposed to be drawing from AB, which in this case is up here, to point C. So we would need to go in a perpendicular fashion, making a right angle to point C. The next segment we're going to talk about is called the median. When you think of median, you might think about mean, median, and mode, your measures of central tendency, and in that context, median meant the middle number when they were listed in numerical order. Well, the median of a triangle is still dealing with the middle. It's just going to be the middle of one side to the opposite vertex. So here I chose this side down here. Middle, remember that means midpoint, so this half and this half have to be identical in length, and so we go from that midpoint or middle up to the opposite vertex, and that line there that's in red, that would be your median. So down here we are going to draw the median from side AB to point C. So I'm going to once again eyeball it, but you may want to use a straight edge or a ruler. We're middle of side AB, so we want to approximate, or you can use a ruler and measure the distance of A to B. We need to cut that in half, so we need the midpoint, and then that midpoint back to angle C. Now it does not have to be a 90-degree angle, it just has to be the middle to the opposite. Here we have that same obtuse triangle we had a few moments ago. So here's side AB. We need the middle of side AB, showing that we're cutting that in half. Use whatever tick marks you want to use, but it needs to show that it's cut in half. And then from point C to that midpoint, or midpoint to C, whichever way you want to draw it. Now in our last example, we have AB up here. We need the middle of AB, and that